Happy Monday, all. Just thought I would spend some time just kind of answering some networking questions tonight. Kind of was bored and thought I would hit up Reddit, see what we had to check on. So I got a couple here. Might be interesting to you. If they're not interesting to you, but you do like the format, go ahead and leave some questions in the comments. I might make this a thing. A bunch of people at work commented that I should, so I'm giving it a go. So first up, we've got the one that actually comes up a lot, even at work where I'm at. Can I only have one, or can I have an LACP port with only one interface? But most of the time when we're talking LACP, we're talking lags, so we're talking putting interfaces together, and we tend to only think of how many interfaces can we put together. 8 used to be really common. Lots of systems today go up to like 32, but we never think, oh, well, what is the fewest I can do? And generally, if you're not configuring it, the fewest you can do is 1. But you can actually set on all of your lag config what your minimum to have the lag up is. So you might want to configure, say, I need to have 4 interfaces up. This could be, for instance, you've got 2 different paths, and each of these paths are, n by 100. They're 4 by 100. But you've got 200 gig of traffic. So if it comes down to we're using active passive, which is pretty common, we might want to fail out one of these if it gets down to 200 because we don't want to start dropping traffic. So we might set minimum interfaces at 3. If it gets below 3, we'll fail out the whole link. But if you don't set that, yeah, absolutely. You can have one link in an LACP group or in a lag group, ether channel, pick what you want to call it. And there's actually some really good reasons why you might want to do that. And the biggest one is upgradability. So if this is, a port that is, say, on a WAN circuit that can never go down, you might start out with a 1. Say I can afford 10 gig into my ISP right now. There's actually a couple of ISPs that this is their standard. I want to say Lumen is one of them, that they almost always do single LACP if you just get a link. And what you can do is you can get 1 by 10 now, and you can pay whatever the price is. And then, in 6 months, you might need to upgrade, and you can add ports into your LACP group, into your lag group. So it's actually not a bad idea. Use it sparingly. I wouldn't use this very often internally because you can spin up, parallel links, and you can switch back and forth, and then do your upgrades that way. But there's a lot of cases where you actually won't want to do this. So yeah, absolutely. You can have a LACP port in one interface. Let's see what people said. Yes, okay. So pretty much people are agreeing. This is only a couple of hours ago. I might actually answer this when we're done here. Oh, there we go. Makes it trivial to add a second link for a throughput or redundancy later. I question sometimes using LACPs for redundancy, but that might be a second video. But yeah, absolutely, you can bring on extra throughput. Yeah, so by and large, everyone agrees with that. Might go in and give some more clarity to that question, just because I've done that a lot. So on to the next one. Here we have a question of Netmasks. Interestingly enough, if you ever are in an interview with some people on my team, this includes myself, I'm going to ask you a question similar to this. So this is actually a good network engineering interview question. Okay, so he's got a network. It's an existing network. Let's see, we've got 450 cameras, 50 PCs, and we've got 2 different subnet masks on the network. So we've got a /23. Older devices tend to have it in like this netmask format, 255, 255, 254.0. We tend to think of that as a /23 on newer devices, but it's mostly comes down to certification, or if you're using older devices that you might need to know that. As manager is telling him, the mask should be 255, 255, 252.0. Okay, so it should be a /22. Oh, and he goes into that down here. So is there any issue leaving all of the devices in the /23 with that net mask, and having the new ones be in the /22? And this is actually a situation you get into a lot. You had a network, I only needed 100 users. But Now everyone's got a phone, everyone's got roaming on, roaming max where another topic I should probably get into is random max on Wi-Fi and how they eat up DHCP pools. But there's lots of reasons your DHCP pool might get used up. And an easy way is to go from a /24. We kind of standardize on a /24. It used to be called class C. It's just kind of a thing. But you might go from a /24 to a /23. And yeah, you can absolutely just grow that. You change it on your router to interface on your router. You change it on your DHCP server config, and you can just go up. If you're using DHCP and everything is DHCP, when your leases expire, actually halfway through when your leases expire, everything will just pick up the new address space, and it'll work flawlessly. And you can do that again. Probably this was a 24, and it became a 23, and now it's a 22. That's kind of how these things grow. But the fact that he's asking this makes me believe that he's got 450 manually configured devices out there. My first thought is please never do that. Anytime that you have to do manual config on devices, you end up in situations like this. DHCP is your friend, but nonetheless, we're here. What is the risk of leaving it? Well, the risk of leaving it is actually pretty minimal. It's devices on the network itself can't talk to each other. So devices on the old network won't know about the new devices. And when you're talking to a network like this, that's probably fine. Where you might run into a problem is if you've got like servers in this network that you need to access. For your camera, you might have your DVR. All these devices have to be in the lowest common denominator. So anything that you need to access from the whole network, actually, the first thing you really need to think about is their gateway here has to be .1. Not everyone uses .1, but this one has to be a .1 gateway. That's the only way you can grow this because, that's the most common way you end up growing it. I guess it doesn't actually matter, but you tend to think of it as .1 because if it's at the beginning, you can always grow out. It's fine. But if it's 254, you can still grow out your gateways just in the middle, and you're going to confuse people for the rest of eternity. But you probably are in this situation anyway. So what happens is your first block is here. Your first block can talk to everything in the block. Your next block is here. It can talk to everything in its block and to the gateway or anything else in the first block that has been reconfigured. And yeah, generally it's fine. Legitimately, my first thought is, why do you have PCs, video encoders, switches, servers, etc., all in a flat network? I wouldn't do that, but you've only got 500 devices. You're probably in a really low security situation. Segmentation is clearly not something you're doing. So yeah, it's going to work, but it's not ideal. And mostly, I think most of the other people are going to say it's not ideal because of reachability. I'm going to say it's not ideal because of security. You really want to segment some of these things out. CCTV is a massive vector for attacks, and having CCTV in with your server network and in with your desktop network, it's got to be firewalled off. I mean, treat it like Internet of Things type situation. It's that scary. So many of these DVRs are lowest common denominators, import goods, and whether or not they're made in your country, made in the USA or whatever, they tend to be made down to a price, and the software reflects that. And I'd be really concerned if you got 450 statically assigned cameras. They're probably all sharing the same password. So my objection to this is from a security standpoint, but let's see what people are saying. It's probably fine. Different netmasks can't talk to each other. Very true. So he's asking a clarifying question, and please use it. So he wants them to talk. Yes, there are ways to do it. On a network like this, we're probably talking a consumer device. There's no good way to do it. There's never been a good way to do it, but enterprise equipment does actually generally still support a way to do this back from when we had multiple routers on the same subnet and we had private VLANs and whatnot. We had what's called proxy ARP. So you could enable proxy ARP and it may just work. It would take some tweaking. I seriously don't recommend doing that. But I could do an entire video on the fun and joys you can do with proxy ARP and source NAT. It's amazing. But yeah, pretty much they're going into what you can, what you can't, getting into, hey, we're working on our CCNA. This is lovely, and it's actually really interesting to see, how IPs and netmasking works. You'll never use this in real life. I've got a good example here. What will you actually do? So you're going to use a tool called SIPCalc. You're going to do this, and it's going to give you everything you need to know. You're never going to compute this by hand ever again. You're going to use a tool. SIPCalc is the one I really like. There's a little IP calc, and there's tons of calculators online. I'm a network architect at a major enterprise. I've been doing this for 27 years. I'm not going to do this by binary by hand. Can't be bothered. Don't feel bad if you can't either. Once you get out of certifications or general, I'm a better network engineer than you are. Everyone just uses tools. It's fantastic. But it gives you your broadcast address. You are going to have to not use all the individual broadcasts for all the 24s. But you'll find a bunch of addresses that just don't work for whatever reason. And just don't use them. But it's going to be all your 255s. So this is probably the gateway. And this would be your top end. You're going to have to avoid 0, 1, 255, these network ones for each of your /24s, because somebody's probably using it. But there you go. There's all you need to know. There's your hash and bits and everything. It's a lot of fun. It's so much better than writing this out. But I appreciate that he went through the effort to do that. It is a good skill. And here we go. We've got 0 security. And that's my big concern. And obviously some meme comments. So it's fun. Oh, here we go. You can't do blah 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 broadcast. This is really old advice. Unfortunately, you can get away with thousands of devices in broadcast in almost every situation. It doesn't matter. We've got routers that are taking hundreds of thousands of broadcasts a second. And you have to tweak your ARP, but whatever. So there are lots of suggestions on what he should be doing. And, maybe leave the cameras alone and move all the PCs, I think is probably the best advice, honestly. Okay, moving on to BGP. BGP is kind of my specialty, so I'm looking forward to this one. He's got a small wireless ISP. Oh, he's got a couple of /23s. That's cool. Those are hard to get these days. Singly peered with Cogent. Okay, I'm sure a lot of people are going to read in the riot act about A, being singly peered, and B, being Cogent. But sometimes that's what you got. He's using Comcast layer 2 services, and legitimately, so is every other provider out there. Everyone is running L2 over everyone else's. You can't have fiber everywhere. This is totally reasonable. All the big service providers are doing it too. Over lots of municipalities, we run a ton of stuff over just the city fiber, and sometimes you get that. I got to get between multiple cities, so you get someone who's going to piece together multiple fiber, and it's generally cheaper to buy. This is generally MPLS, often called Metro E. And it's perfectly fine. Okay, so he's got another WISP nearby. He could get a link between them. Okay. Okay, so he's single provided or single homed to one provider, and he would like to fail over through his neighbor. And this is totally cool. this is a peering relationship, and peering relationships are the basis of the internet. Um, Everybody today thinks of transit, because we go by transit, and that's our thing. But the internet was started with actually peering exchanges, and you would go to one of these exchanges and you would peer with a bunch of other people, usually with just a port fee, and it's fantastic. It gets you really good service. Highly recommend it. Not enough people do it today, and there's so many little boutique ISPs that, I'm serious, are in data centers with these exchange points, and they're not taking advantage of that. They're sending all of their data out. Expensive transit. Transit's expensive. I mean, that's probably part of his issue here, is he can't get a second transit just because of cost. So yeah, you can totally do this. And where did I click? I don't actually know how to use Reddit. I don't know how to use computers. I do engineering, and I call help desk. So yeah, that's kind of the way that is. So what should he do? He wants to talk about weight and med and all of these things. Okay, so when you're talking BGP, you learn about orange soda and all of these things. And they're cool and they're great. And yeah, you've got so many knobs that you can tweak. And when you are running your own BGP network, and it is just you, tweak these knobs to your heart's content. They're great. They're fantastic. You can do anything you want. If you are going between ASs, between autonomous systems, so between networks that you do not own, you really only have one knob, and that knob is AS path prepending. It's a transitive property, and yeah, that's just what you're going to do. It's the only thing that's going to matter. The other thing you're going to do is you're probably going to want to route defensively. And this is true both of, hey, I want to peer with this one guy. This is also true of internet exchange points, IXPs. You want to control your egress. And the way you control your egress is going to be local pref. So in theory, you don't actually need to do anything to set this up. All you have to do is prefix list. As long as you exchange your routes with your peer and they exchange their routes with you, you're good. When you talk then about transit, you're probably technically also still good, because it should be one hop. This, though, gets into the territory of being sneaky. Lots of... Okay, so this is... transit costs you money. So you are going to have this inclination of you want to local pref everything toward your partner and make them pay for your transit. Don't do that. That's all there is to it, because there is nothing you can do to prevent the other side from doing that. So when you enter in with a peering agreement like this and you share a full table, you have to have a lot of trust. You've got to really, really trust the other side. What are some options to get around that? I guess don't share a full table. Send a 0/0 in, send a default route in. We used to call it a route of last resort. We think of service providers being default free zones, but if you only send a default in, they're always going to take the longest match. They're always going to go out the provider. So yeah, I mean, that's what it comes down to is, how do you make this work if you have absolute trust? Is you just simply advertise. You're going to be one hop further for them. They're going to be one hop further for you, but your routes to each other are going to be preferred. So you're not going to have to pay for transit between yourselves. I mean, little boutique ISPs, you're probably not going to have a lot of peering traffic, but in a perfect world where everybody was trusting and everyone was good, you wouldn't need to set any metrics whatsoever. But we don't live in that world, so route defensively. And not just route defensively, do all of everything defensively when you go to another provider of any kind. If you are sharing VRFs because you're doing MPLS for your customers, you want to do type A, you want to have a separate peering for every single one. Your layer 2 should block everything. I mean, I tend to allow LDP just because I think it's nice, but you really should block everything else. Other than that, yeah, all you're doing here is being defensive because it'll just work. Just the path vector is going to be further. So let's see what some people say here. Don't mess with met or wait. Okay, very true. Set a higher local pref for the roots. Okay, so this doesn't matter. You're always going to go out your cogent peering if it's up because it's going to be a shorter path. If you want to guarantee it, I mean, you might do an agreement with each other. You know, if you've got an engineer on the other side, say, hey, we're going to local pref out. The problem with this one, though, is now you're going to route your peering traffic out through cogent. So maybe you want to exchange some communities. Agree, hey, I'll local pref you higher. There's some great examples if you go into some of the BGP books on just how to do provider-style communities. So maybe you want to do that, but I'm gonna disagree with this. Don't do that because you want to encourage peering to your transit partner to be good and prepend the routes you're sending to them. It's great, but they can override the prepend. So I mean, this is not very defensive. It's good potentially, but then again, if their provider is cogent and you prepend your local /23s in this case, you're still going to be wasting transit. So okay, that's fine. Local pref is for everything. Local pref is okay. So local pref is not for everything. Local pref is actually only for eBGP into IBGP. Local pref within IBGP doesn't matter, except in really weird cases. Yes, prepending to the backup path. Yeah, I don't agree with this. Oh, so this person's talking about shared communities. Okay, so what they're talking about here is your provider. Okay, so this is actually a good way to be defensive. You should know what routes they're giving you that are theirs, and there's a variety of ways you can do that. The easiest way is just to do a regex on it just for their ASN, single, final, something like that, and then prepend those as you go out to your provider so that you don't take any traffic in for them unless they're hard down, even if they've done something silly. So yeah, I might consider that one. I actually do like that. So yeah, that's the first thing you probably want to do is you want to set up on your peering with Cogent that you want to prepend their paths out. Just that's how you'd be defensive about it, I guess, honestly. And you probably want to prepend it 3 times. Not anymore. A whole different topic. The more you prepend, the more you're at risk of a BGP attack. They're talking you could tell Cogent to reject them and stuff. Yeah, sure. Yeah, they're not going to probably do this. So yeah, I mean, this really comes down to a lot of trust. I think do an ASN regex and prepend their routes out, and certainly have a policy to send nothing but their routes and your routes out. I mean, you want to be clear that you do not send a full table to Cogent. You do not want to be a transit, path for Cogent. Hopefully they're blocking it all, but the number of times that I have seen providers not do good blocking is just crazy. Okay, so here's another option you can do. You can be more specific. Send your /24 routes out to Cogent so you guarantee yours comes in. This isn't defensive routing though, because this is just a guaranteeing that you pay more money. You're less likely to go through them, but a longest path match will always come in. Yeah, just be really careful before you do this. Just really trust the other side, and prepend their routes out to Cogent. Cogent does support a number of communities, as he was mentioning up there. talk to Cogent, get the communities, and what you can do is on their routes, you can send a Cogent, I'd really like you to set this local pref 50. Obviously, they can do the same thing on the other side. Yeah, just be really careful when you're using someone else's transit. It's a risk, but it does give you a backup path, and if you've got trust, you can do it. So yeah, I guess that's where I'm going to end today. I don't know if I'm going to post this, but I enjoyed going through this. I hope if you watched this, you enjoyed and you learned something. If you've got any questions, leave them in the comments. I imagine I'm going to put this up on YouTube, and yeah, if you enjoyed this, I will do some more. If I get enough people following, I'll do some of these live because I had fun. So thank you all for watching.